Hello, I am teacher Guohar Huang. Today I would like to introduce Unit 6, which is how to analyze questionnaires. In this unit, I will introduce the validity and reliability, expert validity, reliability analysis, single sample t-test, independent sample t-test, dependent or paired, sample t-test, variance analysis, covariance analysis, Pearson correlation analysis, and chi-square test to you. First, let's talk about validity and reliability. Validity means that your questionnaire can ask what you want to measure and whether the design is reasonable. Reliability refers to stability and consistency. That is, the results of each measurement should be the same rather than different or unstable each time. Take target shooting as an example. If a gun is fired and the bullets that hit the target are scattered, there is no validity and reliability. If the bullets are concentrated and consistent but do not hit the target, there is reliability but no validity. If the bullets hit the middle but need to be focused more, there is validity but no reliability. The last one is what we want. The bullets are very concentrated and hit our target stably, and both reliability and validity are excellent. In order to make the questionnaire consistent with our goals and answer the questions we want to ask, we may need experts to review it for us. The method with expert validity is to design a questionnaire by ourselves, then ask 2 or more experts to provide suggestions for review and modification. And then we will make modifications in accordance with the review and ask these 2 experts to confirm the questionnaire until all of us think that it is okay before we can achieve the validity of the expert. One of the simplest and most commonly used ways to measure reliability is Cronbach's alpha coefficient, which can be calculated using SPSS without knowing its internal detailed formula. However, the calculated Cronbach's alpha coefficient must be greater than 0.7 for high reliability. If we want to know whether there is a significant difference between the mean of a group and another group whose mean is a specific value, we can use the single sample t-test. The following 3 examples use the single sample t-test. The first one is whether there is a significant difference between the mean satisfaction level of Class A and that of a group with a mean satisfaction level of 3.5. The second one is whether there is a significant difference between the average English midterm test score of Class A and that of a group with an average score of 60. The last one is whether there is a significant difference between the average weight of a group and a group with an average weight of 80 kilograms. The concept of independent sample t-test is to compare 2 independent groups, unlike the comparisons based on fixed values. For example, whether there is a significant difference in height between boys and girls, whether there is a significant difference in English midterm scores between Class A and Class B, or whether there is a significant difference in attendance between students in the School of Design and students in the School of Engineering. When comparing 2 independent groups for the same value, the independent sample T is used, and only 2 groups are allowed. Comparing whether there is a significant difference between the 2 groups depends on whether the significance of the p-value is less than 0.05, which will be mentioned later. A dependent or paired sample t-test checks whether a significant difference exists between the means of 2 values in the same group. For example, whether there is a significant difference between the mean scores of English midterm exam and Chinese midterm exam in Class A, where everyone in the same group of students has 2 scores, or whether there is a difference in motivation before and after learning in the same class, where everyone in the same group of students has 2 motivations, or whether there is a difference in weight loss before and after weight loss, where everyone in the same group of students weights before and after weight loss. So, these are all dependent or paired sample t-tests. If 3 or more groups are to be compared, ANOVA must be used. T-value is used for independent sample t-test, while F-value is used for ANOVA, which is an F-test. ANOVA can be divided into one-way and two-way. Usually, one-way is used at the beginning. One-way analysis of variance, ANOVA, refers to whether an independent variable will affect a dependent variable. For example, whether there is a significant difference in the average income of families in the North, Central, South, and East districts, with a total of 4 districts, each of which has an average income figure. Or whether there is a significant difference in the body weight of students from the 4 colleges of science and technology, humanities, management, and design in the university, or whether there is a significant difference in the midterm examination results in English of the A, B, C, and C classes. All these can be analyzed by using the one-way analysis of variance. Now, we will introduce the two-way analysis of variance, two-way ANOVA. Two-way refers to the fact that there are 2 independent variables. For example, whether there is a significant difference in students' learning satisfaction between students with different prior knowledge in different pedagogies. The first independent variable is different prerequisite knowledge, categorized as high and low. The second independent variable is different pedagogies, which can be classified as teaching methods A and B. Another example of the systematic approach of two-way analysis is in investigating the cognitive load of students with different cognitive styles using different digital learning tools. This methodical approach allows for the analysis of various combinations, such as 2 or 3 different cognitive styles and 2 or 3 different digital learning tools, ensuring a comprehensive understanding of the data. In addition, whether there is a significant difference in the preference for different types of robots among different grade levels, and whether there is a significant difference in the acceptance of using various modes of transportation among different genders can be analyzed using a two-way analysis of variance. Now, we will introduce the analysis of covariance, ANCOVA. Covariate analysis needs to exclude differences in the pretests. As the experimental group and the control group mentioned earlier, they may not have the same ability at the beginning. We need to take note of the ability at the beginning. We should not just look at the post-tests, and the pre-tests should be the same before comparing the post-tests. However, no matter how comparable the pre-tests are, there is still a difference, so it is only fair to exclude this difference. If you want to lose weight in a competition, the weight of the 2 groups will be the same at the beginning, but it is usually not the same. There will be more or less differences, and then you need to rule out the differences. ANCOVA has 2 categories, one-way and two-way. One-way ANCOVA refers to the effect of only one independent variable on dependent variables under different treatments. For example, when comparing whether there is a significant difference in the learning effectiveness of 2 different teaching modes under the exclusion of pre-test differences. Learning effectiveness refers to the post-test. This test must first exclude the differences in the pre-test, and then compare only different teaching modes are one independent variable, so it is a one-way analysis. Exclude the differences in the motivation of learning before comparing whether there is a significant difference in the learning motivation between different genders. Only the different genders are the independent variables, excluding the difference in original body weight, and comparing whether there is a difference in the weight loss effect of 2 different weight loss methods. Only the different weight loss methods are independent variables. These are all one-way ANCOVA. Two-way ANCOVA will have 2 independent variables. For example, whether there is a significant difference in the learning effectiveness of different genders in different teaching modes, whether there is a significant difference in the post-learning motivation of different genders in different teaching environments under the exclusion of pre-learning motivation, where gender is one factor and teaching environment is another, thus it is two-way. The exclusion of pre-learning motivation is a covariate analysis. Excluding the original body weight difference under the comparison of different ages in different ways of weight loss affects whether there is a significant difference. Age may be divided into adolescence, middle-aged, and old age, 3 different age groups. Another commonly used method is Pearson's product moment correlation analysis. It compares whether there is a correlation between two numbers. For example, whether there is a correlation between height and weight, whether higher height means heavier weight, and similar questions, or whether there is a correlation between age and income, whether older people have higher incomes, whether there is a positive or negative correlation between the two values, or whether there is no significant correlation. Pearson's correlation analysis does not detect nonlinear correlations, such as exponential or logarithmic correlations. Correlation analysis cannot directly make causal inference. Causal inference must be consistent with the independence of variables, temporal sequence, and correlation, and usually also needs to refer to the literature on the logical process of deduction. Correlation analysis alone is not enough to directly determine the causal relationship between variables. Now, we introduce some examples of Pearson's product moment correlation analysis. Is there a correlation between motivation and gain scores? Is there a correlation between time spent watching videos and test scores? Is there a correlation between height and weight? Is there a correlation between Chinese and English grades? Is there a correlation between cognitive load and academic? The chi-square test can be used to determine if there is a correlation between categories. For example, is there a correlation between different genders and different political parties in Taiwan? Is there a correlation between different genders and different religions in Taiwan? Is there a correlation between different regions and different political parties in Taiwan? Finally, please follow your own research topic and experimental design to find out which type of test analysis is reasonable for you to use. That's today's introduction. If you have any questions, please discuss them with me. Bye-bye.